All right, let's go over converting polar coordinates to rectangular. That can be seen on the left, and on the right we have converting rectangular to polar. To keep this simple, let's write down what we need to know and what we know. In this exercise or set of exercises, we have what we have on the left hand side of the equation, which is actually not typical. You're not going to see that on the exam. You sort of have to identify based on the coordinate itself. For example, this has pi, so it's most likely a polar coordinate, right? This one over here, on the other hand, just has like integers or radicals and things like that. Normally, a polar coordinate will contain the right hand side of the coordinate being either a radian or a degree. So let's look at the left hand side. Here we want to convert 6 comma pi to a rectangular coordinate. So to start off, let's go ahead and label it. We're going to be given r, or we are given r and theta, and we need to convert to x comma y, which would be our rectangular coordinate. So let's start off by writing the formulas that include both x and y, and that is x equals r cos theta and y is equal to r sine theta. Just recall that the way we came up with this really stemmed from knowing that sine theta is equal to y over r, and we simply just solved for r. And we did the same thing for cosine, and so we focus on just having these two. The reason being is because it's going to give us rx and y, and that's exactly what we want. So if you're barely sort of getting the hang of this, just make sure you are writing the equation in formula format and then plug in the values that you have. This means that here we have x equals not r cos theta, but rather 6 cos pi, right? And here we would have y equals 6 sine pi. And as a result, we have x is equal to 6 times cos pi. If you recall, based on the unit circle, pi is -1. Just as a reminder that if you have a degree on the calculator, it will be wrong, right? You're computing a radian because pi is radian. So make sure you have your units to compute correctly on your calculator. This gives us -6, and for the y, we have 6 times sine pi. That's 0 actually. So we end up with -6 comma 0. So x comma y is equal to -6 comma 0. And then we are done. So you're going to use this formula that we just used for number 1 to do numbers 2, 3, and 4. I will go update those on Canvas with the solutions themselves. But I'm not going to have them all worked out. Now let's look on the right-hand side, number 5. Take this almost the same approach you did with the left-hand side, in that you wrote with the formulas you knew and labeled information you have, right? So here we have 0 comma -3. In this particular case, we don't have to label it because it's to the left, but you won't have that on an exam, so don't just take it for granted, right? Just label. We need to take this so that it becomes r comma theta. Now, how do we obtain that? Well, looking back, recall that theta is equal to a function that includes both y and x. And the only function that's going to do that is tangent, and that is y over x. Now, we do the arctangent because we're looking for the theta. A lot of people tend to continue to overlook what theta means and sort of just take it for what it is, right? understand that theta is a degree or a radian. Therefore, it could come out to be 300 or pi over 6 or pi over 3. That's exactly what we're trying to compute in order to fill in this spot here. Now, the r, as you may remember, is derived from the Pythagorean theorem, essentially. And so that's just going to give us r equals the radical of x squared plus y squared. As before, write down the formulas and then just plug and play, right? If you just jump into the plugging in, you're not really thinking about what you're doing. You're kind of trying to just let the calculator do all the work, and you might not get the level of understanding you're really trying to obtain here. So let's plug in y is -3, and then 0 is the denominator. On the other hand, we have for r, that's radical x squared, which would be 0 squared, plus y squared, which would be -3 squared. Just one last thing here. One thing that happens a lot is that we leave out the parentheses here. Now, once again, it's just formality, right? You want to maintain keeping the numbers inside the parentheses, what you see for x and what you see for y, although when you square it, they both will become positive, right? So at the end of the day, the negative sign might not mess you up, but at one point, if you enter it wrong in the calculator, that could mess you up, right? So as you're writing it, again, you are sort of thinking about what you're plugging in and thinking about what you're doing. Let's look at this theta here, which becomes arctan -3/0. If you put this into the calculator, if you put it in degree or radian, it actually won't come out wrong. But just understand that if you left it in degree, this is a degree. Most commonly with these problems, though, they would like for you to actually keep it in radians. So keep that in mind and be consistent with it, more importantly. So let's assume we had a calculator and we plugged this in, okay? If you did, you would notice that 0's in the denominator, and therefore it would yield some sort of syntax error. What that means is that doesn't mean that it's not possible. That means you have to sort of do it by hand. So we start by drawing a graph, and then you plot the point. Don't look at this arctan, what's in here, the -3/0. Rather, look at the 0, -3 as a coordinate, because that's what it is. So 0, 3 puts us down here, and it's a point down here. The question now becomes, what theta, what angle do we have to move so that we open up all the way to where -3 is? That yields 270, but once again, we want to keep this in radians, so it's 2 pi over 3. Now, if you leave it as 270, it's not wrong, but once again, if someone asks you specifically to write it as a radian, then you could run into some problems. So this is the theta we're looking for. So this is what we found. Now, we haven't computed r yet, so let's go ahead and do that. Here we would have radical 9, right, which then equals 3. So our solution here is r theta, which r is 3, and theta is 2 pi over 3, okay? Just a quick reminder on this, once again, is to check the units on the calculator and make sure that you don't go on autopilot and assume that this has no solution, right? The other thing that could happen is that if it does work in the calculator, instead of you getting 2 pi over 3, you could have gotten negative pi over 2, right? But in most cases, you don't want to deal with the negative. Therefore, you want to get its counterpart that's positive, and that is 2 pi over 3. I can't speak for everyone in that is negative pi over 2 going to be accepted. Sometimes people who are grading won't dock you for it, but if it does say something like this in your instructions, and this is something of this form, consider that your solution is going to be between 0 and 2 pi, right? Between 0 and 2 pi, you only have positive values. So in that case, negative pi over 2 would be wrong. Or similarly, it would be 0 between 0 and something like 360 degrees. If you had something like that, then you would need to enter a positive value once again. But in most cases, when you would run into that issue, you would know beforehand. Cool. So attempt these problems out, and I hope to upload the solution soon.